Look at another graphical representation of limits. I'm going to take this function. Here's my line, and there's my curve, right? My graph, my axes, and let's put a curve up on that. So I'm going to give you this function now. Okay, and let's, Kauthar, can you give me a value for this here? 5, okay. And can you give me a corresponding y value? 10, okay. Okay, now, people, let's carefully evaluate this. Let's say, Iman, can you name the function for me? Can you give this function a name? Thank you, Ahad, who's named the function d. Okay, so this means that d is a function of x. In other words, you put in an x, you get out a value of d of x. Iman of them. Okay, so thank you for naming the function there. What we now look at is the limit, and we're interested in x approaching what? X approaching what? X approaching? So that specific x value that we are approaching is the limit as x approaches what? 5. Right, very good. Okay, and now we evaluate partial limits. We look at the limit when we come from the right, and we look at the limit when we come from the left. So I'm going to say the limit is x approaches 5 from the positive side, right? And I need to define that. That's the limit of which function? Kauthar, Azra, what's the function called? D. So the limit as x approaches 5 for the function d of x. Okay. So when I run along this line or on the function, sprinting there, okay. Now, where do I end up? Come, where do I end up? At 10. And now, if I run from the left hand side, I'm also considering the limit as x approaches 5 from the left hand side. Not f of x, what's this function called? D of x, right? And I run and I run. Run. Take your fingers, run on the curve. Okay, and where do you end up? Also at 10. Now we say that these two partial limits are equivalent. In other words, the right hand side limit equals the left hand side limit. And when that is true, we can now say that therefore the limit exists, right? Now I need to teach you one other thing still, and that is how to define this. You now write this out as one thing. When the limits are the same, you can now drop this minus and this plus, and you say if the limit exists, you can write out the limit as x approaches 5, that's an arrow, is of d of x is equal to what? 10. Right? It's now, because the right hand side and the left hand side are equivalent, the limit exists, and you can write that out like this.
Now, is that a closed circle?
That's an open circle. In this particular case, what is happening?
So it doesn't really affect that.
It doesn't touch. The 10 is not part of the graph, but it's still the limit. Because we are getting close enough.
Okay, so it doesn't change that if it's closed.
If it was closed, it's still going to be 10.
Okay.
Are you with me? Okay, which is what we're going to look at next. Okay, very good.